Functions of electrolysis part 4, rechargeable batteries. The fundamental thing about a rechargeable battery is that when you are recharging the battery, the reaction is the opposite or the reverse of your discharge reaction. When a battery is being discharged, it functions like a galvanic cell, where oxidation occurs at the anode and electrons are lost. They travel through a wire until they are gained at the cathode. This is something you've probably come to terms with at the end of year 11 or the start of year 12, where you have a battery which is discharging and it's converting chemical energy into electrical energy. Now, what happens when that battery goes flat? Well, two options. You can either throw it in the bin if it's a primary cell, or if it's a secondary cell and those products are still in contact with the electrodes, what you can do is force electricity back into the cell and recharge that battery. And that's where it starts to get into the road of, or into the territory of electrolysis. Let's have a look at this particular electrode here, where B solid is being converted into B positive ions and electrons are being lost. During discharge, this is happening and this would be oxidation, so therefore the B electrode here would be the anode because oxidation is taking place. Now, if I run out of B solid, I'll need to recharge it. So instead of creating these B positive ions, what I need to do is I need to force these electrons back onto my B to form more B solid. So what I'm doing is when I'm recharging at this electrode, I have the opposite reaction occurring. So therefore, what was once oxidation during discharge, it is now reduction during recharge. In my diagrams here, you can see a diagram of a discharge cell. Let's look at this blue electrode, for example. This is the anode. Now you can see it's the anode because oxidation is taking place here, because I can see these electrons are moving away from my electrode here. If I come over here to the recharge version of this cell, and the blue electrode here is now going to accept these electrons, which makes it the cathode because reduction and gain of electrons is now going to occur here. The other thing you need to be aware of is in order to recharge a battery, you need to provide enough voltage to overcome whatever reaction would have happened during discharge. So if a battery produces 12 volts, to recharge that, you need to provide more than 12 volts because you need to be able to push electrons in the opposite direction to the way that they normally want to go. But that's about it. But the most important thing is that you apply your knowledge of electrolysis and redox reactions to every single question, because every question will be unique.